Hello everyone, welcome to this video where we're going to be looking at how we can utilize S-Frame's integration with the Multistory Designer capability of S-Concrete to design our reinforced concrete elements for our entire concrete structure. And we're going to be working through this process. For a bit of background, the Multistory Designer is a utility within S-Concrete that facilitates the import of concrete section data, the associated loads and positions within the structure, into the S-Concrete Multistory Designer that helps facilitate the assignment of reinforcement on a global basis that can be refined on section by section basis as well. It can do the code checking at both a high level and detailed level, just like you would out of a regular S-Concrete design. And it can generate S-Concrete files for your entire structure, as well as produce detailed engineering design reports, schedule-like reports, and more. So we're going to look at how that can be done. And this example that I'm working with, we're going to be using the following 10-story structure that we can see. This is a concrete core structure that has reinforced concrete columns as well. I have some link beams in between the core walls, and the floors themselves are just generated as rigid diaphragms. I've already ran the analysis. I have a variety of different loads, and I can just showcase some of the results here. If I turn off the rendering, it might be a little bit more clear to see. Let me just select one of my load combinations. So one of my load combinations has dead load, live load, and wind loads. And here we can see the deflections, the reactions, axial force moments, shear diagrams, and so on. And in addition to that, we can look at the forces in our walls. So not only can we see that we have different forces within our walls using the contour diagrams, but we can actually integrate those forces into either wall forces or pier forces, which I'm doing in this situation. And I'm able to see, for example, maybe I'll just drill down to just those pier forces, and I can see the forces, the moments, and so on in each one of those piers. And that's what's going to be exported into S-Concrete for design, amongst other things. So here I'm going to go back to the geometry window, and this process really starts after we've built the model in S-Frame, assigned our sections, which we can see here we have a variety of concrete sections that have been generated either using the concrete button or the shapes button. So long as those shapes are available within S-Concrete, we're able to actually design those in this process. They've also been assigned a concrete material. So once I've done that, I can go to the File menu, and I can go to the Export option and say export this to an Access MDB file. It's going to ask me to export it. I'm going to overwrite the one that I was testing earlier, so I'll just click Replace. And it comes up with this dialog that allows me to determine what information I'd like to include in that MDB file. So I want to include all the load combinations. I don't need the load cases. I'm just looking at factored loads in this case. I also need to include the member forces, wall forces, and pier forces. I also have this toggle that says include all input data because I do want to know the section sizes that are coming in, where those sections are on which story. This model is actually built using S-Frame's Multistory Builder utility, so it knows where each story begins and the next one ends, and it has that information in the vertical stack of geometry. So I'm going to click the OK button to generate this MDB file. And the file's been generated. I'm just going to open it up here just to showcase what's in there. And it's worth noting that there's plenty of other applications for this MDB file export in S-Frame. S-Frame can read in MDB files. It can also obviously write them. And naturally it can be used in the Multistory Designer. But there's plenty of other reasons. You may want to post-process data or pre-process data within this format. It's basically a collection of different Excel spreadsheets, or spreadsheets essentially. So here I can see, for example, my joint load data. I can see the results. I can see the member end forces. I can see pier forces in my load combinations, and much more. I'm going to close this, and I'm now going to open up S-Concrete. And within S-Concrete here, if we go to the Run menu, we have the option to access the S-Concrete Multistory Designer. Now the Multistory Designer, it works with S-Frame as well as E-tabs to bring this data in. And in this example here, I'm already pointing to the 10-story MDB file that I had worked on earlier and exported. And now it's giving me the option to control what information I'm going to bring in and how it's going to interpret that. So I'm going to click on this pier shapes option here because I have a number of piers in my model, and you can see that we've got a total of 20, one at each story essentially representing that C-shaped pier, and I can actually group these together. So here I can click on Manage S-Frame Pier Groups, and I can create my own custom group assignments, and I'm just going to call this one East Pier. And for the East Pier, I'm going to say that I have Pier 1, 3, basically every second pier included in this pier group. Once I have my selection, I can just add it over to this group. And I'm going to do the same thing for the West Pier, just grabbing everything else and bringing them over. And now it's going to group those different piers together so that the worst case demands from one will be used to design the different piers in each group. So click OK. I have these two design groups set up now. I can also control whether I want to bring in my columns, my piers, beams, braces, and those sorts of things. I can even set up filters, so if there are certain components that I don't want to bring in, for example, maybe I want to ignore this brace, I can ignore that. I can ignore piers or load combinations. I can even designate them as seismic or other load types. I'm going to click OK, and I'm going to click the next button. Now we're basically detaching ourselves from that MDB file, reading all that information into the S-Concrete Multistory Designer. And this next step of the Project Concrete design standards is actually a very important step to help facilitate this design in an efficient manner. So we can initialize all the different design sections, doing this by setting our design code first. I'm going to choose the CSA 19 code. And in here we can go into, for example, the different shapes or the different types of elements we have. I'll start with walls. And I can specify my minimum vertical bar diameter. So here I might want to go with a starting vertical bar diameter of 25 m. And we can specify our target row vertical steel. And the reason we want to pay a bit of attention to this at the start is because this will initialize all of our different section design groups with this information. So it's our starting point, and it helps reduce the amount of individual edits that we'll need to make to our sections after we've actually generated them. So we want to make sure that this is representative of our design intent. I can define all these different parameters here. I can go to the columns and beams and do the same thing. So maybe I want to increase the vertical bar diameter for my columns again, for example, as well. Once I'm satisfied, I can click on the Apply Design Standards to all sections. And the Multistory Designer has now brought has now taken that information and generated my section design groups based off of that initial input information that I gave it. So I'm going to click OK, and you can see we have a tab for our columns, we have a tab for our beams, and we have a tab for our walls. And if we just look at that, we can see the utilization ratios. For a wall, we seem to be doing okay. We have 4 different design groups. We have our East Pier and our West Pier design groups, as you can see here. I also have my individual wall integration lines. So these are actually what comprise our piers. So we have a 2-meter wall and a 6-meter wall. And these can be designed as individual panels as well, in addition to the piers that we're already designing. And we can see our utilizations all happen to be less than 1, which is handy in this case. We're performing an initial high-level check, in this case here for walls. It's doing this just for the axial check. So this has utilization ratios. Let's say DCRC equals 0.25, so that's the demand capacity ratio for compression is 0.25, and for tension it happens to be 0 for this case. And so we can actually get an understanding of the high-level performance of our model for axial checks at this stage already. And I can actually drill down into this section in more detail. I can click on the wall form, and here I could see the section that I'm importing, the dimensions, the reinforcement that's being used, the number of bars, the size of bars, and so on. And I can make changes as well. So if I wanted to reduce the bar size, for example, I could do that here. I could go to a 20 M bar or do something like that. I can also run the full S-Concrete code check. I can click on this button, Run Code Check. And not only will it do the high-level compression and tension capacity checks, but it's also doing all the other moment interaction with axial loads, shear and torsion checks as well. So you can see here, when we consider the effects of axial load plus moment, we actually have a utilization exceeding our capacity. So this may be a case where we want to increase the number of bars or increase the zone length or do something to alleviate that burden on our wall. So I'm just going to add an extra bar, click apply, click OK, and we can obviously run that full concrete code check in just a few minutes here on all of our sections. Then we can update sections en masse as well. If I wanted to say, well, I want to update, well, I'll go to my columns here and I'll say I want to look at my columns, and both of these columns, 800 and 600 millimeter diameter, they're using 25mm bars, but maybe I want to use a higher vertical steel area. I could increase that from 1% to 1.2 just by selecting both of them and just typing in row vertical steel equals 1.1 and clicking update. It's going to update that for me and my utilizations will reflect. In this case here, I probably didn't need that large of or that much vertical steel for this example, so I could even bring that back down. So let's just go back to 1 and maybe even use a smaller bar size. Once I'm done making these modifications, and I'm not going to go through and check every single section at this stage, but I obviously could do that, and if I were designing a real structure, I'd want to spend the time. But once I'm done, I just click the next button, and I proceed to this step where we can actually generate the S-concrete files. So we can choose whether we want to generate just the columns, just the beams, just the walls, or all three, or a combination of all of them. And we can choose which load cases or combinations we want to include in that list as well. I'm also going to make sure that I've deleted any previous SCO files from the folders they're generated in, just because I've been testing this model beforehand, and I don't need to look at those older files. They don't need to be there. So I'm going to click Create S-concrete files, and this is where actually the process of importing the data can save the most time, because this is oftentimes a very tedious and time-consuming effort to generate these files manually. So I'm going to click on this button. And we can see here that S-Concrete's Multistory Designer has generated all these files for us. So we can actually open up these S-Concrete files now at this stage and use them as if they were built directly within the S-Concrete interface. However, we may be more interested in now running S-Concrete in batch mode. So I can click on S-Concrete Batch Run. And in just a few seconds here, I'm getting a batch run complete message, and now I can look at my results. So I can see view code check results, and I get a tabular format of my, in this case here it's showing me my wall report first, and it's running the full S-concrete code check. So you can see here it's considering shear, it's considering axial load and moment, and not all of my walls are passing at this stage. This is something we can go back. This is not meant to be just a unidirectional process. We can go back and modify these. We have a number of different warnings with all the clause references as well that we can examine. This is for my beams, and it seems to be all acceptable, and for my columns, which I have some warnings in unacceptable status I would need to resolve. In addition to that, I can create other reports. So I'm going to jump into the batch utility, however. And here in the batch processing and reporting utility, obviously I can run batch processes on my sections from this location as well. But here we have this reporting utility, which was what I'm trying to highlight right now. If I click on report options, I can control what data goes into this report. Maybe I want each section to start on a new page. I can control whether or not I want my loads or ignore my loads from the reports, just because they can sometimes take quite a bit of space. Once I'm done, I click OK and create report. And we get a detailed S-Concrete design report out of this that's showing us a tabular format for all the information that we've chosen to include. So I have my columns in this case here, and they're all hyperlinked, showing me the status, shear, and torsion, and axial load and moment utilizations. Continue scrolling down and I can see all of those. And I can see them for different sections that I might be interested in. This case here, I just generated them from my columns. But this is the full S-Concrete engineering design report that we would normally see one section at a time, but this can include tens, hundreds, or even thousands of sections all in one consolidated and nicely organized report. Now, something that I didn't do in this exercise is I didn't go through the process of actually separating my design groups into stories, and that actually holds a lot of value. So if I go back here and I look at my walls, for example, I have my east pier and my west pier. I'll just focus on those for now. Each one of these can be generated into different design groups. Right now they're assuming that all the different piers at each height along the height of the wall will basically contribute to the demands on each one of those design groups. However, we may want to actually design them separately as we go up in height of the wall. In that case here, I could say, well, let's include stories in this design group. And this is showing me all the different stories that this wall exists on. And I can create a new load case, or a new design group rather, for each story. I'll click create update for each. And if I just hide this here, there's no need for me to keep the original section group because they've now been separated into different stories. So I'm going to delete that one. I'll do the same thing for my other pier as well, the west pier. I'll say let's include stories here. And I'm going to make it for each story, create an update, and get rid of the original, and delete. And now I'm just going to proceed here. And basically, if we just look a little closer, you can see that each story now has its own design group that's associated with it. So I'm looking at the stories at that group. And that can be helpful if we have sections that are perhaps over-designed for some load that is somewhere else in the structure. They're all designed based off of their incoming section names or their pier labels and so on. So we can actually filter that out more using these story identifications. I'm going to click next here, and I'm going to generate these S-Concrete files again, but maybe I'll just focus on the walls for now. And now that code check is done, and obviously I could look at the same results that I saw earlier, but I want to introduce a new type of report that we can also generate. If I click on Create Report, I'm going to go to this option here that says HTML Schedule, and we're going to generate a schedule-like report. I'm just going to ignore the wall integration line contributions, the two panel types that we have, and just focus on the piers in this report, and click on Create Report. And you can see here that it's showing me a utilization ratio for each one of these stories, essentially. So it starts with base. So it's a schedule-like report that's showing us story by story the performance of this particular section. And I have both pier groups, so east and west pier. It's showing me the demand capacity ratios. It's showing me the reinforcement information in the vertical bars, horizontal bars, and zones as well as the overall status, and a little rendering of that as well. Now for this particular model, I have the same wall on each side going up the full height of the building. However, this might be more practical if we had, or more insightful perhaps, if we had different elements that were not necessarily extending the whole length of the building or height of the building. We would see those end at perhaps halfway up or wherever they end, and it would just give us a better idea of the performance of our elements relative to their vertical position in the building. So hopefully this provides you with a bit more insight into how this process works in S-Frame to the Multistory Designer. If you would like more information, a great place to look is under the Help Contents. And if you search the Help Contents for S-Concrete Multistory Designer or MSD, you can find a help topic on this very topic, and you'll even find a nice little guide that explains the general workflow for how to go through this with a lot of useful tips along the way. So I encourage you to take that, check that out if that's something that you're looking into.